So there's 4 things we want to do this evening. We want to just do a couple of more of these scheduling exercises to make sure everybody understands it from last week. We'll have a quick look at the Brightspace to make sure everybody can see what I've put up there. And we will do command line stuff. We will do some PowerPoint. This is going to drive me nuts. We will do some deadlock material, and I'll explain why we're doing that when we get there. And finally, we'll have a quick look at discussion over the CA1. All right. So let's just kick it off first and check everybody is. And if you have any questions, just lash them into the chat and I'll pick up on them. All right. So let me just turn on week 2. Make it so hidden. That would be good. Okay, and there we go. Student view. Right. So if you go in now, you should see what I'm seeing. All right. And I've put in a CA description. We'll come to that in 1 second. So week, why doesn't week 2 come up? Right. This is a disaster of a night so far. Week 2. It helps if you make it visible, Pierce. Right. So now, if you go in, this is what you should see. Okay, so this is what you should see. We'll come back to that CA description in 1 second. So week 2, right? If you go in there, you should see deadlock and RAG diagrams. We'll do them in we'll do them after our little break. All right. I'll come back to those. So I want you to go over and just click into CA description. So that's just description of your CA1. We'll go through that before the end of the night, so everybody's clear on it. But essentially, you're going to get a mixture of command line questions, some scheduling questions, and some theory questions just to keep you honest that you're keeping up with the material. Okay, it'll be worth 20%. The CA2 will be worth 30% because essentially we'll have only done 2 nights work for CA1, whereas we'll get to do 3 nights work for CA2. All right. So as I say, I'll keep an eye on the chat and I'll just keep going otherwise. So last week, so I rechecked the video. Oh, sorry, that is while I'm on it, just to show you that. So the video, sorry. Can we kill that? Right, sorry about that. I've added a video to your playlist, right? So these are the first 2 were the 2 that were there from last week. And that's the video of what we did last time. That's the command line video that I suggested you have a peep at to get yourself familiar with the command line stuff. And this is one of the 2 videos I promised you, which was the OS intro one, the other one being the processes one. And the reason why I've only got one of them is I did the 2 of them and I had them ready and everything. And then I realized that me them up when I was doing the video, I hadn't shared the screen. So I had lovely sound, but I had no screen. So I had to redo them. So that one's done. The other one is yet to come. So I'll get that done in the next day or so, and I'll put it up there. So they were just the videos for the 2 first lectures that we didn't do in person, but I'm sure you've had a peep at. But I'll put up a video of that. Right. So scheduling. We did the last day we were here. We went through scheduling. We had a look at. I had a look back at the video. So we did the FIFO ones, and we did the SRT one, okay? And what I'm going to do is just to make sure everybody sees another example is we'll do the round robin one here together. Okay, so the whole point, as I said to you the last time, is the question will always be in this form, right? The question I will give you on the CI1 will be in this form. You will get a table of processes. There will be 4. They'll have 4 different arrival times and they'll have certain service times. And you will be told what the algorithm is. It might be round robin, it could be SRT, it could be shortest job first, or it could be FIFO. And the question will be in 2 forms. I will either ask you to create the Gantt based on the table, and I should say, a separate question might be, I will give you a Gantt and I will give you, say, the table of processes, and I will ask you to calculate waiting times and turnaround times. So that's the way the question will work. I will never ask you to go from the table to create the Gantt and then answer waiting times and turnaround times on that, because if I do that and you make a tiny little error in the Gantt, all these waiting times and turnaround times are automatically wrong. So that's not fair on you, and believe me, it's impossible to mark. Okay, so what we'll do is we'll run through this round robin one, okay, together. So hopefully, I hope you practiced them. I hope you had a go at them. The solutions I put up there as well for you. So your solutions are there. So there's your exercise, there's your solutions, okay? And the way to practice these is try the exercises, then check the solutions. And if you're wrong, try to figure out where you're wrong. If you're right, great. But don't just look at the solutions and go, oh yeah, I know how to do that. Because believe me, then you won't know how to do that. So my recommendation is do as I say. Right, so let's have a go. So we have all these processes deriving at this arrival time, this service time, and it's round robin. So in order to work out the Gantt, we fill in the process, right? So each one of these chunks is 10 milliseconds, all right? So the quantum is 20, which is essentially 2 chunks, okay? So anybody tell me, or anybody going to hazard a guess what we put in the first one? 1, 2, 3, or 4?
1.
1, I agree. So will I put in 1 twice, or will I just put in 1 once? Which will I do?
Twice.
Okay, so, and you said twice because of what? The quantum?
The quantum size.
Okay, but what about the fact that another one arrived in at arrival time 10? So another one arrived in right here. Does that have any effect on round robin?
Everything has to have equal quantum size, doesn't it?
Yeah, unless it's finished, okay? So just don't get confused with that. Round robin is a preemptive schedule, but its decision points are only after the quantum is up, all right? So that's fair enough, I agree with that. So we get to here. So now we've done 2 chunks, so that's a quantum. So what do we put in next? So Francisco says 2. And so there's 2 more in the system at this stage. So 2 and 3 have arrived in, right? Because 2 arrived in here and 3 arrived in here. So we have a choice between 2 and 3. But the way round robin works is it's totally fair. So whoever comes in first gets a go. So we'll give it another 2, yeah? Now we're at this point, and what do we put in here? 2 3s. Okay, is 4 already in the system yet? No, 4 comes into the system here, okay? So again, don't get confused. Sorry, that'll be 3, apologies. 3, 3. Now 4 did actually come into the system at this point here. But it's okay, because round robin, again, we use up the quantum. So at this point, then we go 2 4s. And now we're back around, right? The round robin loop. So what do we put in? We put in another 2 1s, I reckon, yeah? And then we'll put in another 2 2s. That appears put in the 2, yeah. Okay. And then what do? We put in 2 more 3s.
3 is gone.
Yeah. So just watch out for that, right? 3 is finished because it was only 20. So what I recommend you do when you're doing these questions is, as you take away, update this, right? So at this point, that went to 60. Then it went to, there's only 40 of that left. This went to 40. This went done. and this went to 10, okay? So what will I put in here? A 3 or a 4? 2 3s, 2 4s. What will I put in here?
1 4.
4.
Right, that's down to 20 at this stage. 4. 2 4s?
Just 1.
1.
Why 1?
There's
It's only
2.
1 left.
Yeah, exactly. There was only the 1 left, right? So that's grand. And then we literally have 1 1, 2 2, 1 1. Okay? So that's what your round robin Gantt should look like. So a little word of warning, right? If you look this up, and let's face it, we all do this, right? If we all go to YouTube and look up other Muppets like me teaching people how to do this stuff, right? You will find videos on all of these, right? FIFO, shortest remaining time, shortest job first, and you will find ones on round robin, right? Be very careful looking at a video of round robin because there's 2 ways to do round robin, right? The other way round robin works, and it's probably the way it works in reality, right? Is if one was in the system, I'll give you an example, right? When we got to this point, where was it? When we got to this point, right? When we had finished 3, right, and we were about to start 4, in some implementations of round robin, 1 would have got in again first because stuff that's on the queue takes priority over new ones that are coming in, right? Because it's literally just sucking stuff out of the ready queue. If you do that, this becomes very complicated, and I didn't want to complicate it. So if you look at the videos online, if you find them, there's another way, which is this way, which is the more straightforward way. So just be really careful if you go looking at videos on YouTube for round robin because you will get confused, I believe, right? So just be careful. Right, so that's the round robin Gantt. Paul, you did it on Excel. Fine, no problem. Now, again, just be careful, Paul. On the CA, you're going to answer everything on paper, right? So you won't be able to use Excel. So just make sure you know how to do it when it's nice and all white, all right? Okay, so let's have a peep at this, right? And let's try keep all those on the one page. Right, so someone want to tell me what the waiting time for number 1 is. So round robin is a good example of doing waiting time and turnaround time because there's lots of in, out, in, out, in, out. So waiting time for process 1. Any ideas?
0.
Nope. So remember what waiting time is defined as. It's defined as all the time you're in the system until you finish that you're essentially waiting to get back onto the CPU. So Lisa's saying 110. Someone else is saying 110. Let's have a look. So essentially, I know why you said 0 because it came in here and it got on immediately, right? But
Yeah.
what you're forgetting is it got hoofed off here, 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 here. I'm not sure if you can see my mouse, but it got hoofed off there, there, and there. So you need to count all those. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 chunks I would take as an answer. So when you do one of these, if you say 11 or 110 in this case, I'll take the answer, okay? So that's fine. So 110 is the answer there. Right, we go again. Waiting time for number 2. 100, somebody says. And the other, okay, there's another tick there. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. But why did you say 100 then? I only counted 9. Why is it 100 is correct, but why? Yeah, exactly. Because it came in here, so it had to wait an extra one there. See that? So it came in at this point here. So it had to wait there, and then these, and you get the idea, right? So that was 100, correct. Waiting time for 3. 20, someone says. Okay, so it came in at 20 and yeah, it got on then. The mistake people make is no matter how many times I tell them, they forget the arrival time, right? So just be very careful. The way I usually work these out is I work them out as if it's from the start at time 0, and then I just go up and take away the arrival time. All right, that's the easiest way I find to do it. So that was correct. That was 20. And the last one was the waiting time for number 4. 50, says Paul. 50, 50, 50. Everybody's saying 50. Okay, let's have a peep. So the waiting time for 4, it came in at 50. So it came in there. So that's one chunk. 2, 3, 4, 5. I agree. 50. Very good. You guys are very good. Right. Let's get rid of those for a second. We'll do the turnaround times. And if you didn't follow it right, don't panic. It's all on the video, right? Verifying OneDrive. I'm getting now, for Jesus' sake. I swear to God. I wish Microsoft would go away and stop annoying me. You can't see this, but believe me, driving me nuts. Right. Turnaround time. Process number 1. What's the answer? Remember, turnaround time is from the time it came in to the time it finishes. So turnaround time for process 1 is actually the whole thing, which is 19 chunks, which is 190. I totally agree. All right. Number 2. Turnaround time for number 2. 160, says Paul. Looks like it might be possible, yeah. From there to there. Okay, so that's 150, but it's 160 because it came in there. Okay, if you count those, that's 160 chunks, or 16 chunks, which is 160. So again, be very careful. It came in there. Okay. If you do one of these and you get within one chunk, I give you half marks, right? But if you're miles off, no, forget it. So in other words, you get within chunk, I give you the benefit of the doubt that you knew what you were talking about. 3. Give me the turnaround time for 3. 40, he says. 40, 40, 40. Where did it come in? There. Finished there. Yeah, agreed. 4 chunks, 40. Very good. Easy, aren't they? I'll have to make them harder for you lot. And number 4. Turnaround time for number 4. 80. So from 50 to there is 1, 2, 3, 4. Yeah, 80. Yeah, 8 chunks, right? Okay, and that's it, right? So between the 2 videos, you have them all done by shortest job first, right? And you can work out shortest job first yourself. And I gave you the answers in the exercise solutions. Okay, so please do me a favor, will you? I personally think out of all the marks for the CA, these are the easiest. Okay, because some people with the best will in the world aren't as familiar with command line as other people. Some people fly through command line, that's fine. Some people find it much more difficult. These, anybody can do these, right? You don't need any previous experience to be able to do these. So please do yourself a favor, especially if you're weak on the command line. Easy with my colored blocks. Please make sure you know how to do these, because you're throwing away whatever, a third of the marks if you don't get these right. And every year I say this, and every year I see people and they leave them blank. They don't even do them, and I can't understand why you wouldn't do them. Okay, especially you've 2 videos telling you how to do them, and I don't think they're that bad. Can we bring blank checked piece of paper? I give you the piece of paper with the. Do I give it with the blanks in there? Yeah, I think I give you the blanks, right? Can you bring some Lego? No, you can't bring Lego. I give you an empty Gantt, right, which tells you the exact number. So you know if you fill in the Gantt. If you don't fill all the Gantt, you know you've got it wrong, right? So in the same way as these start out like this, I give you something that looks like that. So I'll give you the squares. Don't worry, Lisa, I'll give you the squares. So if you fill it out and you get to here, right, and you stop there, you've done it wrong. Or if you're out here somewhere, if you're out on the right hand side of the page here somewhere, can you see my mouse? Then if you fill in beyond the squares, you've done it wrong. Would you have any additional practice? For God's sake, I gave you 4. right? So make some more up yourself. If you want to make some more up yourself and send me the answers, I'll correct them for you. But no, I'm not giving you any more. I gave you enough. What do you like? Okay, right. Any other questions on those before I leave them? Because I'm not coming back to these now. Yes, service time is the same as burst time. You've been watching too many videos, right? Okay, cool. Right, so I'm not going to come back to this unless if someone has a query and they send me an email, and I think everybody needs to see the answer because it's something maybe I haven't made clear, I'll send it to everybody in an announcement. Otherwise, yeah, I won't be talking about this again. All right. Okay, let's go have a peep at command line. Now, this isn't my night because when I went to use Google Cloud, it started puking, saying it wasn't going to work. I don't know whether anybody else has this problem tonight. It won't let me fire off a Linux box, which is very annoying. So hopefully it has recovered its life. Otherwise, I'm going to have to do it on. Same here. Right. Okay. Interesting. Which is very annoying. Let's see what they say. I have a plan B. Okay. Right. Right. My plan B is I'm going to do it. I'm working on a Mac, so I'm going to do it on the local terminal. So unfortunately, unless you have a plan B, you're not going to be able to practice. Do it as we go along, but at least you'll have it on video. And then when Google wakes up, you hopefully will be able to practice. And hopefully you looked at the video, and considering it's nearly an hour long, and there's loads of good information in there as well. Right. So let me set up. See, can I get it to work on? It should work. So let me see. Week 2 prep. Right. So we did already have a peep at some of these last week. So they were the questions. So I'll just put those there. And what I need to download is q.text, right? Oh, I need to go in. I need to. They were not working. What wasn't working, Francisco? The questions on awk. Oh, anyone in particular? Which questions are you talking about? I didn't ask any questions on awk. Broken links. Oh, sorry. What do you mean? Apologies.
Yep, yes. 2 of
Yeah.
the links were broken last week. Yeah, I couldn't get to them.
Oh, okay. Do you know which ones?
If you go back.
Was it this one? Week 2 prep? One of
Yeah,
these?
these
Weren't working.
No, the bash questions with hints on the text file. I think, yeah, 2 of those were not working. The others were just links to.
The top 2 weren't working.
I think so.
Did everybody else have that problem? First 2 links
Yes.
don't. Oh, okay. All right. Let's go and fix that and see. Can we? You should have told me before now. Bloody, I swear to God, Microsoft to do your head in. Right, hold on. Let's try and sort that. So this is the q.text link, right? So let me just go in and let's fix it. A free tour of. Okay. Interesting. That's very strange. Yeah. Okay, so this is going to be the bash questions with hints, right? So I'm going to redo it, and then we're going to see, can you open it? Okay. Oh, sorry, it was 2 prep, wasn't it? Okay. Link. Okay. Do me a favor and see can you open bash questions with hints now, will you? Okay, that is really odd. Okay, well that's, you should have told me before now. But it's fine. We'll fix them. Fix them. Q.text. Right, here's Q.text. Strange.
Hi,
Yeah.
I'm still unable to open this text file.
Are you logged into your TUD account?
Yes.
Then you should be able to get in. Someone test the Q.text one. I've only just fixed the Q.text one. So what's not working for you, Sean? The bash questions with hints. Oh, Q.text, I hadn't fixed it. I've only just fixed Q.text now. So they both should be okay now. Can everybody see? Can you see them? Working. Sean, can you try Q.text? Okay, and sorry, I don't know who the lady was that just spoke there. Can you check bash questions?
No, it's not working. The bash question is working, but the Qtext file, there's something wrong. It says something went wrong.
Okay, just refresh your screen and go into Q.text again, will you?
Okay, 1 second. I'll do that. Thanks.
So that's all it is.
Yes, it's working now. Thank you so much.
Sorry, no problem. I'd say if that ever happens again, anything like that, just mail me, okay? Because obviously there was something wrong there. Okay, right. Let's go back and see can we actually do some work, right? So that's the actual bash questions with hints, and that's the Q.text file, right? So what I'm going to attempt to do is do it. Okay, of course you're not going to see this. Okay, that's fine. We can fix that in a second. You can't see what I've just opened, yeah, because I'm only sharing my browser. You can't see that I've just opened my terminal. Sure you can't. So I just need to stop sharing for a minute and reshare. So bear with me for 1 second. Can you see my terminal window now?
Yes.
Right.
Yeah.
Cool. Okay, so what I'm going to try to do, okay, so I'm on a Mac, right, which is essentially Unix, yeah, but should work. All the stuff should still work. Move text. Let me know if anybody gets Google Chrome to work, Google Cloud to work while we're doing this. Okay. So anyway, whoa, move. Right. Okay. I'm just going to set up a alias here. Okay, in this directory, I now have just Q.text, right? So let's go and have a peep at the Google Cloud is now working. Bloody miracle. Hold on a minute. It's typical, isn't it? People must have been screaming at them because this has been broken for about an hour or so. Maybe they're just like you, Shane. Oh, yeah, all right. In fairness to them, I've never seen that happen before. For that length of time. Of course, you now have X million people. You're getting Tarek's not working for you now. Oh. Let me just give it a second. As I'm pretty sure I can do it. I'm pretty sure on my Mac terminal, but it's really for you, so you could play along if it's working.
It took ages to load there, but it's after coming up for me as well.
Yeah, I'd say what's happened is I'd say they had a major problem, and now of course they fixed it, and every time Dick and Harry is coming back in, so it probably will work for you, Tarak. It's probably just timed out. So we'll just give it a second and see how it comes. It's probably as ropey as BJ's is now because of this. Okay, I'll come back to that in a few minutes, right? So let's have a look. What are we trying to do here? So this is our q.text file, right? This is what it looks like. And I showed you this last week, and I gave you the questions. So let's just go through them and see what the story is. So the first question, so what am I going to ask you, right, in the CA? I'm going to ask you to be able to use these commands to get information out of a file, right? Now, I'm not going to ask you anything that involves sed, all right? If you want to learn sed and awk, that's great. Sorry, the links, or sorry, the sed links, the sed and awk links did work. Some people love sed, some people love awk, especially people who are familiar with command line, right? I know how to do certain things with sed. I know how to do certain things with awk. It's one of those things that unless you're working with it all the time, every few days, you will forget. Having said that, they are extremely powerful. But I will not ask you any question in the CA that you have to know sed or you have to know awk to be able to do. Having said that, some people every year give me back the answer using sed and awk, which is fine. I'll correct it, and if it's right, you get all the marks, right? But I won't. Basically, anything I ask you will be reasonably basic command line stuff, or will involve one of these or more of these commands other than sed. Okay, so all these questions here, you can answer nearly every single one of them, bar two, without using sed. All right, so let's have a peep through them and see if we can get them to work. That's still having a go there. I'm glad we didn't wait for that. Right, so we have q.text. So again, if you ever want to look into a file in command line, it's just cat, right? Is that big enough for you? Can you see that, guys? Let's make it a little bit bigger. Okay. That's a bit better. So cat q.text, right? Cat will just show us what's in a file. It's short for concatenate. So that's what the file looks like. It's the same as what I showed you here. Right. So the question was, create a new file with just the first and the fourth word on each line. And I gave hints. I won't give hints in the CA1. Let me make that smaller so I can see if you ask me a question. Okay. I won't give you hints in CA1, so you will have to know what command does what. So cut is a command that allows you to rip out vertical, let's say, columns or chunks out of a file, right? So in this case, we want the first and the fourth word on each line. So let's go have a look. Did anybody figure out how to do it? Be hard. Well, it would be pretty hard considering you couldn't see the questions. But you never told me. So does anybody know how to use cut? How about that? Does anybody know how I might get the first and the fourth word out of each line? Any ideas? Here's my team's gone. Any ideas? Oh, okay. So cut. How cut works is you can give it fields. So I want field 1 and 4, right? And I want to specify what the delimiter is. If we look at that file, what do you reckon the delimiter is?
Space.
Space.
Space, yeah. So 1 space. So let's go have a peep. So we can say minus D for delimiter. And if you just put in space, right, that's not going to work because space is used on the Linux command line to separate commands. So if you want to say the delimiter is space, you need to specify it between quotes, right? Q.text. And if you do that, it'll rip out the first and the fourth word, which is what we want, right? So does that answer the question we got asked? Does that answer it? Or was there something else in the question? See what it said there? Create a new file. Yeah. So I need to put it in a file. So let's go back and have a peep. So by default, right? If I do that, it goes to the screen, agreed? So I can redirect that to a file by literally typing a file name here. So we call it 1.txt and putting in 1 character here. Does anybody know what that character is?
Greater than.
Yeah. So what that is the redirect sign, okay? It's just 1 arrow and it redirects the output. Instead of going to the screen, it goes to a file. Now, seems to have worked. There was no error. So let's have a look inside q1.txt. Use cat again to see what's in a file. And yeah, that's done. That's it, right? That's the question. Now, for those of you who do want to, if you wanted to learn something about awk, right, you could do the same thing with awk. And like this is going to look gobbledygook to some people, right? But I'll explain it in a second. To some people who like a bit of programming, this will actually probably make more sense than the cut thing, right? I won't do the redirect this time because we understand that. So what awk does is, don't worry about you need those, right? But all they're basically saying is, in between these is what I want you to do. And what it said is print parameter 1 and parameter 4 on every single line with a default delimiter of space, right? So if I do that, I end up with this. Now, the only problem is, see there? I don't actually have a space in between. So we can fix that by actually telling it to explicitly put a space in. Well, sorry, apologies. I explicitly put a space in using quotes. And I get the same answer, right? That's if you wanted to do it with awk. But as I say, please don't worry about awk. I'm not going to ask you to do anything with awk. It's just some people use it. That's the last thing I'm going to mention about awk. So the next question was create a new file with the first 3 lines and the last 3 lines. And again, I suggested use head and tail. So let's have a look. Anybody know how to get the first 3 lines of a file? Head 3, someone says. Well, you've done a couple of weeks of scripting now, have you? Or have you only done 1, or have you done 2 weeks of scripting? Two weeks, very good. And who's teaching you scripting? Art. I know Art well. Very good. So you'll be experts very soon. Excellent. So by the time you come to do the CH, you'll be brilliant. Okay, so if someone said head. Someone said head 3, q.text, right? So if I go head 3, q.text, it pukes, right? Because you just need to put a minus in, right? A -3 or a -n3. You don't need the n. That will give me the first 3 lines, right? How do I get the last 3 lines? Again, I gave you the hints, right? But how do you get the last 3?
Tail.
Tail. Exactly. Tail, -3, right? So if we were able to combine those two, we'd get the answer, wouldn't we? It said create a new file with the first 3 lines and the last 3 lines. So let's try do it. So how do I put the first 3 lines in a file? There's my first 3 lines. I sent them to the screen. So how do I put those, how do I redirect those to a file? To a file called q2.txt, right? How do I put those in a file? What was the symbol we said? Arrow. Very good. Arrow. Okay, so q2.txt now contains the first 3 lines, but we also want to put the last 3 lines. So if we go head, if we go tail, let's see, what do we put here to put that in as well? So Sergey says, hopefully I got your name right there. He says 2 arrows. Why 2 arrows instead of 1 arrow? What does 2 arrows do?
Append.
Yeah, exactly right. It appends. So that's what that's going to do, is it's going to append the last 3 to that. So now if we have a look with cat, we see the 6 lines we want, yeah? And that's it, it's done. Now, sometimes, be careful, I might ask you to do something in one line, one command line, right? So let's do it in one command line. So what did we have? We had, no, you can't pipe it, it won't work. Pipe is a different problem. I'll show you pipe in a minute, right? So I've got that, and I've got tail -3 q.txt, and we have this, right? So has anybody got, if I want to do the 2 of those on the same line, any idea what we would put there to do that? Yeah, very good, Francisco. If I put a semicolon, it's like, so you've all done probably a bit of Python at this stage. A semicolon goes at the end of each line to tell the compiler, this is a new line we're going on to, a new command. And it's the exact same with the command line, right? You can put in a semicolon and it'll do the 2 commands essentially on the one line. There's another thing you can use other than the semicolon. What's the other symbol I could use to combine those 2 commands to run on the same line? Anybody know what it is? Any ideas? Well, I'll tell you, it's this, right? Yeah, very good. It's and. So I want you to do this and do this. It's not that, right? That's a different thing. That's a logical and, which we won't talk about. That means and do this command, right? Now there's numerous ways you can do this on one line. I'm just showing you my battery is long. Yeah, that's okay. I'll get probably until the break. That's okay. I can get my power supply. I'll keep an eye on it. Thank you very much. You're very good. Very good. Right, so we try that. And let's have a look in q2.txt. And that's cool. That worked, right? So we got that one. Excellent. Next one. Count the number of characters in the first 4 lines. And to do that, we're going to use 2 commands. We're going to use WC and we're going to use head, okay? So the number of characters in the first 4 lines. So how do we get the first 4 lines? Well, we know how to do that, don't we? Head -4 q.txt, right? And what's the command? I mean, know the command to count the number of characters. WC -C, very good, right? If I want to count the number of lines, it's WC -L. If I want to count the number of characters, it's WC -C. If I want to count the number of words, it's WC -W, right? So characters. So now there's a symbol I can put between these 2 commands, and we'll do all this on one line. Anybody know what it is? Is it the answer is pipe, yeah? So Pedro's right, that was Pedro. The answer is pipe. Now, why isn't it an arrow? Why isn't it that? And then the question then becomes, well, when do I use an arrow and when do I use a pipe? Maybe you know the answer to that one. Because believe it or not, that command to command, yeah, seriously, very good. So the way this can be quite confusing for a lot of people, right? The easiest way to remember is do not use an arrow unless there's a file involved. In other words, you're sending the output of a command to a file, or Another way you could use arrows the other way is to read from a file into a command, but I'm not going to do that with you. I'm sure Art will. I'm going to keep it nice and simple. If you use an arrow, it means you're redirecting the output to a file. If you're redirecting the output from one process to another process, right? Or as Sergey said, from one command to another command, you use a pipe. And think of the pipe as if you turned it horizontal, the water would come in the pipe one side and out the other side, right? In other words, it's just linking two processes or two commands. So if I do this, I get 135, which is the answer, okay? So that's how I use a pipe. Now I could have, right? I could have done this. And then I could have done yeah, and I get 135. Yeah, and if I really wanted, I could combine the two of those on one line with a semicolon, and I'll get it as well. So there's lots of ways you can do it, right? But the proper, the best, the most efficient way, the nicest, prettiest way is using a pipe, okay? So hopefully you got that. So let's go back and have another peep. What's the next one? Count the number of unique lines in the file unique. I wonder if we got good with it. Ah, here, Jesus, will you go away? Leave me alone. That's nuts. Refresh. Okay, count the number of unique lines in a file, right? So, a number of unique lines in this file. So I'll tell you now, there's, if we do minus L q.text, that counts the number of lines. There's 40 lines, right? There's only 8 unique lines. There's loads of duplicates in there. So if we do man unique, right? It says filter out repeated lines, yeah? And it says the unique utility, blah, 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 comparing adjacent lines. That's a very important word, that adjacent thing, right? So anyway, it should filter out repeated lines. So let's see, does it? So unique q.text, yeah? And let's count the number of lines. Still 40, right? So it looks to me like unique q.text didn't do anything, right? So why didn't it work? Why didn't unique do what it was supposed to do? Anybody know? And it boils down to that word adjacent that I showed you. The other way to get help, by the way, is if you type minus help on most commands, it'll give you a bit of help. On Google Cloud, it gives you loads of help. That's not very... No. Google Cloud, if you go unique minus help, it gives you loads of help. This is obviously Unix BSD, but anyway. Right. Anybody know? So, yeah, Paul got it, right? The problem is, yeah, that word right there, adjacent, yeah? Unique will only work if the lines are adjacent. So if you think about it, if you were trying to code this, yeah, you would make it easy and say, well, if this line is the same as the previous line, I'll just get rid of it, yeah? Whereas if you had to track every line and there was other lines in between, it would be a lot harder. So what they do is they say it has to be sorted first. So sort q.text unique WC minus L, right? What will I put between here? Arrows or pipes? Any Linux on pipe? Yeah, pipe. Everybody agrees pipe, right? So again, we'll put in the pipe. Yeah. And we've 2 pipes now because what we're going to do is we're going to sort the file, and I'll show you what that looks like in a minute. We're going to pipe that output through unique, and the output of unique we will then count. So let's do it. Let's do it. Well, I'll tell you, we'll run it, and the answer is going to be 8, right? It's 8. But let's have a look and see what actually happens. So when we sort it, that's what went out to the screen. But what we're saying is we're not going to send it to the screen. We're going to send it to unique. And when I do this, now I get, can't see that. When I do this, I only get 8 lines, right? Because it has got rid of all the duplicates. And then when I do the full thing, it counts the number of lines in that output, all right? So that's the difference between pipe. Now, I could have done this in 3 stages by going sort q.text, put it in a file. unique that file, put it in another file, and WC minus L on that final file, and I still would have got 8, and that would get you the marks as well. It's not as pretty, but it will get you the marks. Right? So figure out ways to do it. Don't always have to use pipe. Pipe is the nicest way to do it. Okay. Next one. Oh, this is my favorite. Did I show you this the last day? How to create a new file with the lines from 10 to 15. Did I show you that? How to do that? Yes, no, maybe, perhaps. I don't remember. No. Okay, good. So you can do it with SED, but I'm not interested in really showing you how to do it with SED. I'm interested in showing you how to do it with head and tail. So you might ask, how in God's name could you do it in head and tail? Well, I'll show you. But let's just open up Excel for a minute. Right? As if Microsoft is feeling generous to me. Maybe it is, maybe it isn't. It's bouncing. Come on, you can do it. There it comes. Right, excellent. Okay, so let's have a peep here. So we said we have what, 40? There's 40 lines in this. File. So we'll make them a nice color, right? Did we see that? We said we want the lines from 10 to 15. We make those different color. Great. Now we see those now, yeah? So there's my 40 lines. I want 10 to 15. And I've suggested do it with head and tail. Anybody, any ideas how I would do that with head and tail? Any ideas? Get the first 15 and then the last 5. Very good. Thinking outside the box, right? So if you think about it, if I were to grab the first 15, it would look something like that, wouldn't it? So if I grabbed first 15 of that file, put it in another file, and then got the last 5, I'd get what I wanted. Let's have a look. So head minus 15 q.text, and then we said tail minus 5. So again, what will I put here? A pipe or an arrow? A pipe. So hopefully everybody can understand at this stage why I'm saying pipe and not an arrow. If it was an arrow and I did head minus 15 q.text, I would just put the first 15 lines into a file. What this is going to do is take the output of that and pipe it through the tail command, minus 5 command. So if I do that, and then, what did I say was the actual question? Hold on. The actual question was create a new file with the lines. Okay, fine, we know how to do that. So it does want a new file. Yeah, and we'll call it 10 to 15.text, right? So what do we put here? An arrow or a pipe? Anybody? An arrow. Yes, because remember, we are trying to put the output into a file, not the screen, right? No errors, looks like it did something. Cat 10 to 15.text. Okay. Is that right? Any ideas? Is it right? No answer.
No, it's not.
Why not? What's wrong with it? You're right, it's wrong.
Yeah,
I'm missing something.
.txt, the file name.
No.
No.
No, I put it in a file called 10 to 15.txt, right? That's my file name. Sorry. It's just,
Oh, okay.
I can put it in any file name you want, right? I'll put it into Q. I don't know what Q this is. We'll say Q. We'll say that, right? Yeah. So is that right? Is that right? Anybody else?
No, it has to be -6, yeah?
Yeah, exactly. It's a little bit of a trick question, right? The reason is 10 to 15 is actually 6 lines. Okay? Bit nasty. Well, it's a bit of a trick question. So that's what it is. So what you actually needed to do was tail -6. Okay? And then it's right. Okay? So just be careful. You can do lots with head and tail, right? For ripping out, I could ask you to take the second line of any file, the second last line of any file, things like that, right? Add a blank line after every 5 lines. You need said to do that. I'll let you look that up yourself, right? Create a new file with every instance of Hugo replaced by Ugly. I'll show you how to do this because of all the things you can do, it said this is actually one that I've used over the years. Again, I'm not going to ask you this in the CA, but actually I think you might find this one quite handy. So I'll just show you, right? Well, first of all, I'll check whether I've got said here. Yeah, I do. Okay, so what did I say? Replace Hugo with Ugly, right? So if I go said, it's as simple as substitute Hugo Ugly Q.text, right? And actually what it's done is, see what it's done there? It's replaced all the Hugos with Ugly. And if I put that in a file, we call it QQ.text, right? And then I suddenly realized, well, that's not right. I can go back, yeah? And one of the commands that was in that video last week was diff, which will basically tell you if files are the same, right? If there's no errors. It's the same if I did it with just QQ, it'll punch out all the ones Hugo and Ugly. Okay. So the reason why I say to you is that's, believe it or not, that is actually quite powerful. Because for instance, you could change it even to be that, right? You could, there's no limit to what you can do with it. You see what happened there? Hugo was put in instead of. So you can, it's very handy if you have a load of files and you've made a mistake and something spelled wrong, someone's name or whatever. Yeah, I'm sure you can open them up in Word and you can change them on it. But actually, there's nothing I've ever found quicker. And you could probably write a Python program to do it. But command line stuff is one of the quickers I've seen on how to do it, right? Create a new file with every line that does not contain Pierce. And the suggestion was to use grep, right? So let's take it one step at a time. If I go grep, right, Pierce, Q.text, there's the 3 lines that contain Pierce, right? Does anybody know how to find the lines that do not contain Pierce? Did anybody look up how to do that? Or sorry, well, you wouldn't because you couldn't see the questions. And we know how to reverse the search parameters. Anybody? So if you look it up, right, minus L, minus I, no, don't think so. Minus I will search for ignore case, right? So it's minus V. If you look it up, it's minus V. So we get all that, right? And there's loads of versions of grep as well. There's egrep, there's all sorts of stuff. And every year, if I ask a question like this, I get different answers as well. That actually would give me, there's 30 lines. There's actually 37 lines that don't have Pierce, right? You can check that by typing it, okay? The other way, sorry, you want to count it. That was the question was count the number of lines, wasn't it? No, it was just create. Yeah. If you want to count them, if I asked you to count the number of lines, if I asked you to count the number of lines that contain pairs, right? What would you do? So we just do that, wouldn't we? And you get 3, wouldn't you? So everybody see how I did that? I just literally grepped and then did WC. There's actually another way to do it. If you know more of the commands, more of the options with grep. If you go grep -C, it will do the same thing, okay? But there's loads of ways of doing these things. These are just quite powerful filters that you can combine together, right? So let's go have a peep and see what else we had. All right, tar. Anybody know what tar does? What was the, well, yeah, Sean is right. It's very like, it's like zip, but what did the other person say? Or was that Sean? Sorry. Archive, yeah. So it's basically how to do an archive. So I think everybody knows zip, right? And you know you can zip files and put them into a zip file and they'll be compressed and they're all there and you can bring them somewhere else and you can extract them and all that jazz, right? So you can do a similar thing with a thing called tar. So let's just have a peep and see what we have, right? So what files have I got here at this stage? So I've got all those files at this stage. So what I could do is there's 3 things you can do with tar. You can create a tar file. Well, I'm going to show you 4. You can create a tar file, you can list what's in a tar file, and you can extract a tar file. And the 4th thing you can do is you can zip it to make it smaller, all right? So let's just have a peep. First of all, tar to create, right? So I'm going to go tar, and then C for create. VF is what is always used. V is just verbose, tell me something, and F is the name, tells it, put the files in this tar file. So I'm going to put them into my files.tar, right? And I'm going to put everything in this directory in there. So it looks like it did something. And you see there we have a my files.tar and it's 17K long, right? If you want to see what's in a tar file, it's tar tvf. Okay? T for tell me. And it's telling you what's in it. Notice, not only does it put the files into the tar file, but it puts in their permissions, their owner, everything, right? And their date stamps, right? So when you extract it, that goes with them. So let's go and extract them. So I'm going to make a directory called temp. I'm going to go into the directory and I'm going to extract them. So X for extract. Why did I put the 2 dots there? Anybody know why I put the 2 dots there?
Directory.
Because they're upper level.
Yeah, because I went into the temp directory and my tar file is actually in the directory above. So I need to tell it, the tar command, where the file is. So if I extract it, it extracted them all. So now I have them all in the temp directory. Yeah. And I have them all in the directory above as well. And if you look, they're the exact same stamps, right? So you can move stuff around, you can tar it, extract it. The other thing I told you I would show you is you can zip it, right? So in other words, not only can you create an archive, but you can create a zipped archive. So let me just remove. I'm going to move the tar file just up for a second because I want to have the exact same content, right? Which is my files there, right? So tar, we had CVF, my files dot tgz. I'm going to call this file, right? So the standard for a tar file is .tar. The standard for a zipped tar file is .tgz. So when you're looking on the web, you might find TGZ files, you might find tar files. That's all it means, right? Tar is just, it's not zipped, and TGZ is, it's a zipped tar file. So the bit I'm missing is, if you want to create the zip version, you need to add a Z there, right? And it did it as well. So I'm going to move my tar file that I put up above. I'm going to bring it back. then I'm just going to show you. There's the TGZ file. It's 1.5K. There's the tar file. It's 17K. So as we expect, the zip file is tiny compared to the tar file, isn't it? So why in the world would you ever use a tar file rather than a TGZ file? And that's the purpose of why I'm just showing you this. Anybody know why? Why would you bother with a tar file when obviously a zipped one is going to be right? Yeah, well done, Sean. The reason is if you have a tar file and you had 1,000 files in there and you're just working on one file and there was a backup happening, say, every 5 minutes or every hour, it would just update the one file. Whereas if you have a TGZ file, you can't update a TGZ file. So tar files are used for incremental backups, and TGZ files are used just for, say, weekly snapshots, daily snapshots, monthly snapshots. But a tar file, you can update the files in there. So yes, they're bigger, but they're very, very good for incremental backups. So say some people might be running these in the background, updating stuff that you changed during the day in case you got hit by a ransomware attack. You could recover everything. Whereas maybe at 4 a.m. in the morning, they back up everything to a TGZ file, or maybe they still do an incremental one and they just do the TGZ stuff at the end of the week or the month, right? So it's very, very important difference. And that's why if you actually try this, it'll fail, because what I asked you to do was create a zipped tar file, and then I said using tar, create a new file with just a list, so that would be the TVF option, and then I said update the tar file with this listing. It'll fail because that was a zipped one. All right. Okay, so hopefully you get the idea, right? So look, I know that's for the people who don't know much Linux. I know that's very quick. This combined with your scripting stuff, plus you have it on video now as well, and you have the other video I gave you. For the people who are weak in it, you're going to have to do a little bit of work, but at least all the answers are here, and you're not going to see anything much different than what I've shown you, okay, and what's on the videos. So try not to get too scared about it, but for the people who aren't very good at command line, but you got to practice if you want to try get some of these, okay? So where are we? It's 10 to 8. So what we're going to do is we're going to take a 10-minute break. Then we're going to come back and we're going to do a thing called deadlock, right? And the reason why it's slides, right? And I'll make it as interesting as possible. But the reason why it's actually a very important topic, and it leads into a load of practical, or I won't say exercise stuff we're going to do in 2 weeks' time when you're into college. And that forms a good part of what will be on your CA2, right? So it's important that you understand, I'm going to have good timing for my battery. It's important that you understand deadlock properly, all right? So let's take 10 minutes. So I'll see you back here at about 2 minutes past 8. Is that okay? Any questions? Not seeing any. If you have any, just ask me when we come back. So I'll see you in about 10 minutes, all right? About 2 minutes past 8. Okay, I'm back. Everybody hear me okay?
Yep.
And excellent. Good stuff. Okay, so what are we going to do? Let's go have a peep here. And you'll be glad to know I have power, which is good. So week 3, 2. And we have 2 things to look at, deadlock and RAG diagrams, right? So deadlock first. Let me download this. We're still loading, it says. Copy. Our dashboard come back? Did this come back? What do you like? That's a joke. Swear to God. Restart. Clean slide. Apps. So they're popular tonight. Wait for PowerPoint. So it wants to open. I think I have a lot of stuff open or something. Yeah. PowerPoint. Bear with me. Okay. Okay. You all see the deadlock stuff there? Hopefully you can. Just move that so I can see your messages if you ask anything. Okay. So as I said, the reason why we're going to do this is it's actually quite important, right? So deadlock is a fancy way of saying I'm trying to avoid my system from hanging. All right. So whether you end up being a programmer or you end up being an IT management person, or you're writing scripts or whatever you end up, right, in this industry. And some of you will start off IT manager, become programmers. Some of you will do vice versa. Some of you become managers, blah, blah, blah. Every single person will come across at some stage, they will write something and they will make a system hang. And a lot of the time it hangs. It can hang for many reasons, but one of the most, I won't say popular, but common reasons is 2 processes or 2 threads are trying to access the same resource, and one is using it, the other's trying to use it, can't get at it, blah blah blah, and you can end up with, if you're not careful, you can end up either hanging your system or corrupting a file or data. So it's extremely dangerous, right? And we'll come across it in a few guises as we move through this module. One of them is deadlock. One of them is a thing called synchronization, which we will do in a few weeks, 4 weeks to be exact. And you'll see hopefully how dangerous and how important it is if you don't watch out for things like this. So in English, deadlock is like the picture on the left, which is obviously a roundabout deadlock. I don't know where that is. Could be in Italy, could be in England somewhere. No idea. It's obviously not Ireland. That would never happen in Ireland. But the easier one to understand is probably if I have a thread or a process, 2 of them, right? And what the diagram is saying there is thread 1 is holding object 1. So you can think of that as a resource, like a file or whatever. And it wants access to file 2. So say it's got hold of file 1 and it wants to write to file 2. And it's not going to release file 1 until it gets access to file 2. But unfortunately, there's this other thread which has file 2 and wants access to file 1. And it isn't going to release file 2 until it gets access to file 1. So you have this circular problem whereby neither of them is going to release until they get the other. And that's the typical example, if you look it up, of a deadlocked system. In other words, it isn't going anywhere. It can never go anywhere unless some operating system steps in and whacks one of these threads, right? That's deadlock. So why are we bothering to even worry about it? Because we don't have an infinite set of resources. We don't have an infinite set of DRAM. We don't have infinite screens, printers, whatever, right? There are always limits. So an OS has to be able to manage these things, and it does it by certain little methods. The one that we'll talk about a lot in 4 weeks' time is a thing called semaphores, right? But we're going to do some of the theory behind it here, because if it says if you're not careful, you can have problems, right? So deadlock is, in order to try to explain it, right? And if you look up the way this is explained, you'll come across these 4 things, these 4 conditions, right? That have to be in existence in order for a deadlock to happen. So again, when you think deadlock, think of the silly little diagram up the top there, right? Which is, I have something you want, and you have something I want, and we both are not going to release what we have, so therefore we're locked. All right. So when you read these 4 conditions, right? Some of the wording is the standard wording. I want you to think of it in English, right? And I'll try to explain it in English. And it's a lot. Some people just learn these off by heart, right? Because if you look at past papers, they come up a lot. But I'd rather you just didn't learn them off by heart. I'd rather you made an effort to try and understand them. Because if you understand them, you can actually remember it much easier, and you can answer questions much easier because you actually understand them, right? So the first one, it says mutual exclusion. Processes claim exclusive resource control of the resource they require. The resource isn't shared once allocated, right? So exclusive control of resource. All that means is if I have a resource, right, I have the whole resource, and I'm not going to give you a bit of it, right? So I'm not going to, if I have a printer, I'm not going to give you access to a bit of the printer, or I'm not going to let you use it for 5 seconds. I have it, it's mine, end of story, right? It's exclusive use. It's the resource isn't shared, right? That's what mutual exclusion means. So that's the first one. The second one is the wait for condition, right? And again, in English, all it means is that while I wait, I want 2 resources. I have one of them. I'm waiting for the other. All it means is I hold on to the ones that I have while I wait for the other ones I need. And that's why, if you think about it, that's why this happens, right? Because thread 1 is holding resource 1 while it's looking for resource 2, and thread 2 is doing the exact same thing. It's holding resource 2 while it's looking for 1. So you are basically allowed hold resources you have while you wait for more, right? So that's the first 2 conditions in English, hopefully. The second 2, and this no preemption one, is sort of very closely linked to the wait for. If a process is allowed hold a resource while it's waiting for other ones, what this says is you can't take it off them, right? So in other words, you're not allowed preempt. You're not allowed remove a resource from somebody. If they have it, and they can keep it. Okay, that's that condition. And the last one, again, related very closely to the diagram. You can relate them all back to the diagram. A circular chain of events or processes exist in which each process holds one resource, and that's exactly what we said. P1 has R1 wants R2, P2 has R2 wants R1, right? That's this idea up here. All right, that's what you have. So the important point is, for deadlock to happen, for the thing to be totally locked, all 4 conditions have to be present, right? Not 3 of them, not 1 of them, all 4 of them. And the opposite of that is, if you can prevent 1 of them from happening, you will never get deadlock, right? So that's a very important point. To get deadlock, because people get confused about this, to get deadlock, all 4 must be in place. Because if you think about it, if I was allowed preempt, then I don't care if you're holding a resource. I'm just going to take what I need, right? So that's just an example. You need all 4 for the deadlock. That's what that says. So again, in English, right? So if I asked you to explain deadlock in English, this is a reasonably decent example, right? So again, relating to the picture up in the top right, which is the spaghetti thing, if you break it down into the space on the road that a car occupies, right? So in other words, we've got 3 green cars, 3 yellow ones, 3 blue ones, 3 light blue, 3 dark blue. I don't know what colours you're seeing because everybody's computer's palette is different, right? But let's apply the 4 conditions to that and see what we get. Mutual exclusion applies. You can't share a section of the street. If the car is on it, it's on it, right? So that's fair enough. Hold and wait. Well, I'm here while I want to get to the next place. That's okay as well. I'm holding the one I have while I get to the next one. Seems fair enough. No preemptive condition. No one can come along with a big magnet on top of my car and lift me off the street. I know theoretically you could, but realistically it doesn't happen, right? So in other words, I'm occupying this, I'm holding it, and you can't remove me from it. So you can't preempt me out of here. And then the circular wait is, well, I'm waiting on the next one who's waiting on the next one who's waiting on the next one. So we have a nice big circle here. All right. So it's a reasonably good analogy. So that's deadlock. So what we're going to talk about is how do you actually prevent it? So we talk about what the problem is. And the easiest way is always remember this little diagram, right? So how do you prevent it? Or how do you stop deadlock is a better word, because there are 3 methods. One is prevention, one is avoidance, and one is detection. So the first one is prevention. And out of the 3, this is the only one that is done as what we call design time. Avoidance and detection, the second 2, they're actually real-time methods to stop deadlock, right? Prevention means you design the system so deadlock can never happen. The other 2, you let the system run and you either try to avoid deadlock or you actually let it happen and then you fix it. That's what detection does, right? So, deadlock prevention. We're going to remove any possibility of it occurring in the first place. In other words, we're going to design it so that it can never happen. So, as distinct from avoidance detection, which are one time. So the goal is to ensure that at least one of the necessary conditions for deadlock can never hold. So remember what we said? It needs all 4 to be deadlocked. So if you can prevent one, you can prevent it. So that's what this is trying to do. So that's what that says. So what we're going to do is let's go and look at the various Coffin conditions and see how could we prevent that from happening, right? So that first one we're going to look at is how could we eliminate the hold and wait one? So if you think about it, I want 2 resources. I have one of them, yeah, and I want a second one. And the reason why we got deadlocked was, well, you know, Jama, who's there, Jama has the other one, and he's not going to give, he or she isn't. Sorry, Jama, are you male or female? Anyway, thanks, Jama. So Jama, he has the other one, yeah? So I'm never getting it. That's the problem. However, if we made it so that if I need the 2 resources, that I have to request them all at once. I have to request them all at the same time, and I get them all or nothing. In other words, I can't proceed until I get them all. Then I could never get in the question. I could never get in the state whereby I have one and Jama has the other, right? I'll either get them all or I have to wait. So that would get rid of that problem, right? So we'd try that one. The other one we could do is we could do the no preemption thing. We could say, okay, you are allowed to preempt. And the way we would implement this would be if you are holding resources. Now, again, the minute you read this, you're going to go, hold on a minute, Pierce. You just said that we weren't going to hold, that you had to request them all at once. Remember, we either do this or we do this because we only have to prevent one of them. So when we're trying to prevent this one, we're allowing this one to happen, the hold and wait, right? So in this one, what we're basically saying is if I have one, yeah, and I go look for another one, and because Jama has it, I don't get it, I have to release everything I have. That's the rule, right? So in other words, you can be going along, you can get them one at a time, but then the minute you hit one that you don't get, you have to give all the ones you have back. So you're preempted, right? So that's how we would design it so we could make sure that could happen. And then the last one is elimination of the circular wait condition. What this means in English, it means you put a number on each resource, and you're only allowed to request them in a certain order. And if you think about it, then if the order was you had to do 1, then 2, then thread 2 could never have got to the state that it went 2 and then look for 1. So if everybody has to only request them in a certain order, then you wouldn't have this circular problem as well. Now, the problem with that is modern stuff, I'm sorry. Well, the problem with all of this is in modern software design, none of this makes a lot of sense because it isn't that simple anymore. There are very, very complicated processes, very, very complicated access to resources. So it doesn't really fly, the prevention and the avoidance one when we do it. The only one that does actually make any sense when you see it is the detection one. And that's the one that is actually used in real life. But we'll get there. All right. So we've talked about the 3 ones there. And why are there only 3? Why can't we prevent mutual exclusion? Well, can you share half a printer, or can you share half a disk or whatever, half a USB stick? The answer is no, they decide not to, right? They let that one happen and they go after, let's prevent one of the other 3. So that's prevention, right? And that's it. That's the words behind what I've just stated there. Is there anything new there? Oh yeah. So the fourth part is what I just stated, right? But it can lead to a waste of resources, right? So in other words, if you need 10 printers, yeah, you have to request all 10. You get 10. Now this is silly, but who'd want 10 printers? But I suppose if there was, insurance thing printing out insurance renewals at night time and it had access to a load of printers, then maybe you might do this. So what this is basically saying is if you need 10 printers, you have to request all 10 at the one time. You'll get them, but then you mightn't use them immediately. So it might be ages before you give them all back, right? So that's a bit sucky. So you wouldn't really do, that's not so good, right? And it can lead to indefinite postponement, right? And what that means, anybody know what that means? Indefinite postponement. In the scope of this, what does indefinite postponement mean? If I needed 10 printers before I could do anything, I had to get all 10. What does indefinite postponement mean? Any ideas? I'm just asking just to keep you awake, by the way. Yeah, exactly. Never happens. I might never get my 10 printers, right? Because the rule is I have to ask for all 10 at the one time. And sure, I'm never going to get them if someone else has them. Yeah. Or I might never get them because someone else might get in ahead of me. So it can end up with indefinite postponement. So that's not so good. So let's go at the words behind the other one, the no preemption. I covered the first paragraph. Again, the disadvantage is you lose all your work. If you're looking for 10 printers and you get to the 10th one, you have 9, and then you ask for the 10th one and it's refused because someone else has it, you've got to get back the 9 you have. So again, not the best, right? And you could end up with indefinite postponement. So that's not so good either. And then this one, right, which is the third one, which is you uniquely number each resource. And the easiest way to explain it is to look at the one with the 2, right? That's easy, but the example here is 5 of them. And it just means that you have to request them in a certain order. And it works. However, very, very difficult to actually code this in modern days. And if you think about it, does it make sense with modern processes that are run on multiple cores that access so many resources and software does so much stuff? I don't think it makes much sense, right? So that's prevention. So the important thing you need to remember for prevention is we don't try prevent the mutual exclusion one. We only try prevent one of the other 3, the hold and wait, the no preempt, or the circular wait. Okay? And we do it at design time, not run time. That's the important points about prevention. So the next one, avoidance. So prevention, you design it in. Avoidance, you dynamically consider every request and decide whether it's safe to grant it. So what does that mean? So it means, the system has a certain state. People have resources. People ask for resources all the time. And the OS decides whether, okay, if I give that person that resource, is there any chance there's going to deadlock here? Okay. That's what it's trying to figure out when it's granting a resource. And in order to do that, it needs more information about the process, about how many resources it needs and all that sort of stuff. We'll have a look in a minute, all the extra information it needs, because that's what makes it unrealistic, right? There's an interesting analogy here. again, if you look at past papers, which I suggest you do, by the way. I think I said this 2 weeks ago. Please look at past papers as early as possible, because a lot of the time people will look at this stuff, listen to this stuff and say, oh God, this is awful. I can't understand this, right? But if you go look at the questions that get asked, you might suddenly get a nice surprise and say, oh, that's not too bad, actually. I do remember him talking about that. And, you know, with the best will in the world, I can only ask a certain amount of questions, right? I'm not saying they repeat. They don't repeat. And please don't try to do some mad analysis to say, oh, he hasn't asked this question in 4 years. He's definitely going to ask it now. Or he asked it last year. He's not going to ask it this year. I don't look at past papers when I write the paper. I literally just write it. Okay. So I don't care about what I asked last year or the year before. I just make up new questions every year. Now, having said that, there's obviously going to be certain things that crop up a lot because there's only certain things I can ask and certain things are more important than others. But I might phrase it a different way. Right? So you've got to understand it rather than learn it off by heart. Anyway, prevention versus avoidance is an interesting analogy. So traffic light versus the police officer. Without reading the last two lines, which do you reckon is prevention? The traffic light or the police officer?
Traffic light.
Yeah, because again, remember we said prevention was design time. In other words, you design in that the traffic light is, say, on for 30 seconds and off for 30 seconds one way and then the other way. Now, I know before you say it, traffic lights have become very sophisticated recently, and there's lovely sensors in the road now that dynamically result in the traffic lights staying on for longer if there's a lot of traffic coming. So actually, believe it or not, the traffic lights have become much better. But if we consider the traditional traffic light, it was literally 30 seconds one way, 30 seconds the other, even if there's no cars on one road, right? So that's like a sledgehammer to crack a nut. In other words, it's prevention, it's designing it in. The cars are definitely not going to crash into each other because I've designed it this way, even though it's not optimal, right? Whereas the police officer is a bit more like avoidance, right? He's dynamically allowing certain traffic through if there's loads of cars one way, won't bother if there's no cars the other way. They still don't crash into each other. In other words, they still don't tail up or whatever, but he's dynamically changing it, right? So that's an analogy with avoidance. So what the hell is avoidance, right? So we said prevention, I'd say poor resource utilization. If you consider the traffic light 30 seconds on, 30 seconds one way, 30 seconds the other way, then it would be pretty bad resource utilization if there was no cars ever on one road, and reduced throughputs. So if we use some extra information, in other words, resources available, resources allocated, future requests, future releases, we can avoid deadlock. What does that mean in English, right? Well, what it means is you'd need to know a load more information per process as regards how many resources does it need, and when is it going to need them, when is it going to release them, blah, blah, blah. It's very theoretical, right? Now, there is an algorithm to do it, and we will do that algorithm, and we will do some questions, right? And it's interesting. It is interesting, but it's not very practical, right? So the important point, though, is with avoidance. You may recall for prevention, we said we would leave mutual exclusion alone and we would try prevent the other three. With avoidance, we leave three of them alone, and the only one we try to prevent is circular weight. All right. So in other words, we're trying to avoid the possibility that someone has something, is looking for something else that someone else has, and they want the thing that the first person has. So we're trying to avoid that simple little diagram, that circular weight there. Okay. So let's have a look and see how we might do it. So in other words, we're saying with avoidance, we actually allow mutual exclusion, wait for, and no preemption. So in other words, what we're saying is when a process has a resource, it can keep it, even if it needs other ones. And we can't take it off them, right? We're just trying to make sure that we never, ever, ever get it into a state that it could deadlock, right? We're trying to avoid that circular weight condition. There's this algorithm that we're going to do in 2 weeks' time is called this bankers algorithm, and there's loads of questions we'll do on it, okay? It's called bankers because it comes from how they used to handle money and accounts and all that sort of stuff, right? Anyway, so what does it actually say? It says, and you won't understand this probably until we do the example, which is just coming up in a couple of slides. It says a resource can be allocated to a process only when the allocation will result in a safe state. So what does a safe state mean? It means that a state in which the total resource situation is such that all users will eventually be able to finish. Okay, so here's the thing you need to make a note of, right? These algorithms for avoidance, or this algorithm for avoidance, it assumes that when you have all the resources you need, you will finish and give them all back, right? In other words, you're not going to keep them and hog them forever. The whole point was you needed X amount of resources, and when the system gives you all of those resources, you are guaranteed to finish and give those resources back, and then the system can give those resources to somebody else, right? An unsafe state is one that might eventually lead to deadlock. You are not guaranteed ever to lead to deadlock because you don't know when a process is going to give back a particular resource, right? And we'll talk about that in a second. So we'll look at an example and then you might understand it, right? So let's pretend, crazy, I know, but let's pretend we have 12 printers, right? 12 resources. And let's pretend we have 3 users. So this is where it gets, as I say, a little bit, to me, idealistic and not very modern. Each user specifies in advance the maximum numbers of printers they will need. Now, in reality, does that make sense in a dynamic system? I don't think it does, but anyway, we will say it does, right? Each user I specify, so one user might only ever need 4 printers. Another fellow might need 10 printers. Another fellow might need 8, whatever. The OS accepts the user request as long as the maximum need does not exceed 12. Makes sense. And printers are obtained or released one by one because we're allowing, remember, with avoidance, we are allowing the wait for and the no preempt. So you're allowed to hold on to resources while you wait for others. So you obtain and release them one by one. And sometimes you might have to wait. But if you follow this algorithm, the OS guarantees that you will get it eventually. You might have to wait a certain amount of time. So here's the example. Let's say we said we have what, 12 printers. And it's basically saying that user 1 has a maximum need of 4. User 2 has 4, has a maximum need of 6. User 3 has 5, has a maximum need of 8. So, go away. So how many are free? How many have we got free? Without looking at the next slide. Anybody? Wakey.
2.
2, agreed, yeah. We had 12, didn't we? There's 10 of them out on loan. So there's 2 free. So without me actually saying any more, which user am I safe to give the 2 printers to?
Second user,
Why?
so they can release them back.
Exactly. See, that's the important point, right? Remember what I said. If you end up getting your maximum need, the assumption is you will use them and then give them all back. So if we gave the 2 we had to user 2, he would have 6, which is his maximum need. So he's guaranteed to finish and he will give back 6. And then user 1 only needs 3 and user 3 needs 3. So we will be able to give them 3 each and they would be able to finish. So that is a safe state that is guaranteed not to deadlock. Okay? So hopefully you can understand that, right? So that sort of takes some of the theory and applies it to a very simple example. Now, the examples we will do in 2 weeks' time, when we're all together in the lab, right, are a bit more complicated than that. And don't worry, if for some reason you can't be there till 8 o'clock to do the CA or traveling or whatever, don't worry. I release videos on how to do the bankers algorithms as well, all right? So yeah, you'll miss me talking, waffling and giving the nice examples and blah, blah, blah. But don't worry, you still get a video on how to do these when they're a little bit more complicated, right? So let's have a look at an unsafe state. So say I have this, yeah? Why is that unsafe? You can look at that and immediately see it's unsafe. Why? What's jumping out at you between the loan and the maximum need compared to what we have available?
User 1 has maximum of 10 is too much.
But what do you mean too much?
Well, if the maximum is 12 and he has an allowance of 10, it's not really well spread, is it?
No, you could still have a maximum need of 10. Depends. What I'm looking for is look at the gap between on each row between the loan and the need. So the gap on the first one is 2. The gap on the second one is 3. And the gap on the third one is 2, right? 1 from 3, 2 from 5, 10. So the gap is 2, but I've only got 1. So no matter who I give this 1 to, they will never get to their maximum need, right? So I am never guaranteed that one of them will finish. They may give me back stuff. And that's why I said it may deadlock, right? If you go back, it said it might. An unsafe state is one that might lead to deadlock, right? So what you're looking for is the gap compared to what I have available. Gap of 2, gap of 3, gap of 2. That is an unsafe state. So the real problem is whatever happened before this allowed it to get into an unsafe state. So if you were running the banker's algorithm correctly, you would never allow it to get into this state because this is crap, right? This could deadlock. It's not guaranteed to deadlock. It could deadlock, and then you'd be screwed, right? So that's basically what that's saying. Okay, it won't. It's not going to. It's not definite it will deadlock, but it could easily deadlock, right? Because none of these users have to give any of these back. They don't have to. They can, but they don't have to. And also, because I'm allowing the no preemption, I can't preempt to take some of them back, right? So that's the problem. Okay, so these are the rules. I'd say I've already really said this, but let's run through it. The OS grants request only if the result in safe state. That's fair enough. So whoever allowed this to happen did not follow that rule. So that's why it's an example of unsafe state. We allow for mutual exclusion, wait for a no preemption. So we allow people to hold them, even though they haven't got all the stuff they need. And we can't take them back. That's what that means in English. And the one we're trying to avoid is the circular wait. You're requesting one at a time, that's fair enough. And if it's denied, the system guarantees that the user will eventually get the resource, right? So what it's basically saying is, if it's going to keep it in a safe state, you might be looking for resources. If I don't give it to you, it's because if I give it to you, it's going to become unsafe. So I'm going to guarantee that it stays safe. Okay, that's what the OS has to do. So you only allocate the resource if the allocation will not prevent the process from completing. So you have to make sure that whatever you do allows one of them at least to complete. Okay, so it's because it's always maintained in a safe state, sooner or later, everything will finish. All right, hopefully you get it. So the good point is it allows jobs to proceed that would have had to wait under a deadlock prevention scheme. All right, so it's theoretically it's fine. The problems are it's theoretical, right? It's not a practical solution, right? So you can read through those and you'll see it's not a practical solution, but it's good for serving a point, proving a point. Okay, so that leaves us with the third one, which is detection. So prevention was design time. Okay, avoidance was runtime. Detection is also runtime. So with detection, what we do is we assume that things are going to go bad, and we're going to clean up if they go bad, right? So in other words, if something bad happens and we get into trouble, we're going to kill a process, or we're going to kill a few processes, and we're going to recover the system. That's essentially what it means. So let's have a chat about the theory part first, because there's diagrams here too, and we will do. I'll show you them, and I'll show you some of them tonight, and then we'll do other ones next week in 2 weeks' time, right? So this is the process of actually determining that a deadlock exists, right? So in other words, you just let the system run away merrily, and you've got something in the background trying to figure out, is this deadlocked, right? Is this going to deadlock? Has it deadlocked? And if it does, well, we're going to recover the situation, right? So to do it though, to understand it, what we use are these diagrams, right? So what do the diagrams look like? So we've got resources and we've got processes, right? So to cut a long story short, processes are circles, right? So in this case, I've got process 7, process 8, and process 9. And don't worry, we'll do loads of these. And then resources are a square, right? So we've R7 and we've R6. What do you reckon the three little circles of R7 are? What do you reckon that means? To say R7 was a printer, what do you reckon the three little circles mean? In there.
They're requested, or
No, the little circles, the arrows we'll do in a minute, they're requests and all that sort of stuff. But if R7 was a printer, what do you reckon the three little circles inside the R7? The three little circles inside the R7 square. What do you reckon those three little circles mean? If R7 means a printer. It means I have three printers, okay? And similarly, say R6, say it was an LCD or whatever, I have two LCDs, okay? That's what that means. So what this diagram, without reading the words there at the minute, what this diagram is basically saying is I have three printers. If you have an arrow going from a resource to a process, it means the resource has been allocated to the process. So at the moment, this diagram is saying I have three printers. One of them has been allocated to P7. One of them has been allocated to P8. And one of them has been allocated to P9. Okay? And then over here, R6 on the right-hand side, I have two LCDs. One of them has been allocated to process 8. And the other one doesn't seem to be allocated at all yet. But I have this arrow going from P7 up to R6. What do you reckon that means?
That resource being given back.
No, it was a good attempt, right? What it means is when a resource is given back, by the way, the arrows will just disappear, right? A request from a process to a resource means the process is asking for that resource, right? It is a request for that resource. So, see, can you figure this out? What's the very first thing you would do with this diagram? What could we do with this diagram? Clean it up a bit. Do we have a spare R6? We've given one. We have two, don't we? We have two R6s with two little circles in there. One of them's been given to P8. The other one hasn't been given anywhere yet. So what could we do with that spare one?
Hold on to it.
Oh, I could hold on to it, but why? No one else. There's only one person looking for it, right? So I could probably give it to him, couldn't I? I could immediately just change that arrow to be over here.
Yeah.
Right? So in the same way as avoidance, right? What you were looking to do with avoidance would get to the stage that a process had everything it was looking for. Because if it has everything it's looking for, what will happen with that process? What did we say? When you give a process its max need, everything, what can we assume will happen?
We'll hold on to it.
No, when you give it everything it was asking for, it'll hold on to it while it's waiting for other ones. But if you give it everything it was looking for, what will happen with that process?
It will probably finish and give it back.
Exactly. It'll finish and it'll give everything back, right? Okay? So that's the important point. You were always trying to get to the stage that process has everything it needs, because then that process will finish. It'll give me back everything it had and I can redistribute it to other people. That's what this is all about, right? So let's keep going for a minute. So we use these a few words and then we'll have a look at another example, right? So we use these to show which processes can complete and which remain deadlocked. So what we're looking for is, hopefully, can all the processes get what they need and complete? Because if they can, it ain't deadlocked. If we get to the stage that, he has something that someone else wants and that someone else has something he wants, if it's you get the circular thing, we're in trouble. We're deadlocked, right? So what we do is we do a process of what they call reduction, right? That's what they call it. And essentially, I'll show you an example in a few minutes because it makes more sense when we do the example. You try and see, can any process finish? And therefore, if it does, let it finish. It gives back its resources. So it's reduced, it's gone. Then you do it again and see, can I find another process that can finish? And if he can, he's okay and he gives back his resources, right? And if all processes can be treated that way, there isn't a deadlock, right? because all processes can finish. So let's keep going for a minute. So once a system has become deadlocked, though, we're in trouble, right? So if we detect a deadlock, then how do we fix it? Yeah. And unfortunately, the way to fix it is to either kill the process and restart it, because if you kill it, its resources will go back into the system and can be given out. Your only problem then is, from a programming point of view, that's quite complicated because that process obviously was doing something. Yeah. So it ain't easy, but that's essentially the only way to do it, right? So it involves forcibly removing a process and reclaiming its resources. The work it's done will be lost. Other processes will be able to continue. Sometimes several processes may need to be whacked in order to allow the thing to recover. We'll talk about more of that in a second. So another way you might be able to do it, right, was, and we talked about this when we were doing scheduling, right? We had this medium-term scheduler, which was responsible for suspending and resuming processes, right? And you may recall suspending meant, well, you know what? I'm going to take you out of DRAM. I'm going to save you over here. I'm going to let the other ones use what they need in DRAM. And then when everything's quiet, I'll bring you back. So that might be an interesting way of freeing up resources so that, you know, other processes might be able to finish. So that's one way you might do it. This one is actually used as well, which is you have some sort of checkpoint facility. So say you had a process and it had to do certain jobs, and say it had to work on one file, then work on another file, then work on another file, right? Well, what you might do is, if it worked on the first file, then you had a checkpoint that you knew that if I have to whack it, I can start from that point again, right? And then you let it run to another, maybe deal with another resource, another file. And once it got that stage, you also put in a little backup thing, checkpoint there, so that if I have a problem after this point, I don't have to go all the way back to the start. I can go back to this intermediate file that I've saved off, right? So that's another way you can try it out for this, right? But here's as I say, this whole recovery does involve work by application system developers to be able to handle this. And to give you an example, right, because I've had experience of this. Anybody know what an unattended device is versus an attended device? Well, I'll phrase it a different way. Some of you probably have worked in retail at some stage, or maybe you still do. When you're using the credit card machine on the table and it locks up, it hangs, what do you do with it to get it to recover?
Reset it.
Exactly, right? Now, the reason why you were able to recover that is because you're standing beside it. It's attended, yeah? What would happen if you weren't there? If it was just a machine on its own? It will just sit there home, won't it? Well, the answer is yes. So an unattended machine is one that there is no user there to plug it in and out or turn it on and off if it hangs, right? So to give you an example, I once had to work on a system that was petrol station pumps. We'll get there, Paul. Petrol station pumps in the back end of nowhere in New Zealand, right, where people would come along with their boats to an unattended diesel pump, and they want to fill up their boats before they go on their fishing boats before they go on their merry way, right? It was an unattended station. The guy would go up, pay with a credit card, whatever, fill up his boat, and off he goes. So you're talking about a fair bit of money here, right? Unattended. Can you imagine the chaos that would happen if that thing hung, right? Deadlocked or whatever. So my advice is, especially if you ever work on a system, and some of you will want to do this, if you work on a system and if there's any chance it's unattended, be it a vending machine or God knows, some remote system, make damn sure that there is something in that system that is monitoring the system internally to see is it still working, right? That can be as simple as processes sending little ping messages to each other, right? To make sure that it's all still working. And if you detect that, if that central control process detects that the others aren't working, it does an auto, or as Paul says, a forced system reinitialization, right? In other words, it reboots and restarts itself, because otherwise you're dead, okay? So deadlock recovery, what I'm telling you is essentially the way you recover from deadlock is you kill processes and restart them, or ultimately you restart the system. All right, but you do it automatically. You don't require manual intervention. And obviously, if you're going to be doing this, you can't afford to be losing data. So you also have to build in some way that data is being backed up as you're going along. All right. So it's complicated, but that's essentially how they do it. Okay. So that's fine. That's what I just said there, right? So factors determining which process to roll back. Okay. It's again, it's all common sense, right? It's priority, right? Say you decided which one will I whack or which one will I suspend. Well, I won't suspend or whack a high priority one. I'll try pick one that is going to cause the minimum amount of hassle. All right, might be one that's sitting in batch mode, so I don't care whether I have to delay this to run at 4 o'clock in the morning versus now. All these different factors. Okay, so I think they're all fairly common sense. So, oops, right. So that's the good news is that's the end of the deadlock theory, right? So we're just going to look a little bit more at the RAG diagrams, and then we'll leave it. We'll leave those for tonight, and then we'll have a quick chat about your CA1, right? And then, as I say, in 2 weeks' time, you'll come in, and from 6:30 to about 28, we'll do more on the banker's algorithm and the RAG diagrams. So practical stuff, no mad theory, right? And then we'll do the CA at about 8 o'clock. All right. So I want to show you the other one. There's a. Okay. So this one, the RAG diagrams, right? Okay, so let's just save this one. And please, if you ever come across a link that's broken like that again, please just drop me a note so I can fix it. All right. Don't wait 2 weeks. One sec. Okay. All right, so let's just have a little look at these RAG diagrams. So what's the process, yeah? So they're the words, but you'll understand it more when we do the example, so I won't spend a huge amount of time on this. It says, find processes that have all the resources that they need, okay? So if you think about it, remember we said, if the arrow went from the process to the resource, it meant the process was asking for the resource. If the arrows went from the resource to the process, it meant the resource had been assigned to the process. So when you look at the diagram, if all the arrows are going into a process, it means that process can finish, right? If it can finish, you can remove the process from the graph, you can release any of its resources, and then you can go and look to see, can I grant any of these extra resources requests to existing processes? And then you basically do it again and again and again. It'll make more sense when you do the diagram, to the example, right? So this is what the key to the graphs are, right? So a circle, as we said, is a process. A rectangle is resources with a certain amount of instances. An arrow from a process to resource means that process is looking for that resource. An arrow from a resource to a process means that resource is assigned to that process. And there's just a simple example, all right? In this case, process 1 has 2 resources of type 1. Process 2 has 1 resource of type 1, and it had asking for a resource of type 2. So let's just do an example. So start on the top left, okay? So just look at the box on the top left. We have process 1 with an arrow to R1. We have P2 with an arrow coming from R1. You see it there. So the first part of the process, find a process with all its arrows inwards. All the arrows are coming into the process. Can you find in that diagram which process? There are 3 processes. Which one has all the arrows going inwards? Any ideas?
R1.
No, someone said P2. So Gavin's right. He said P2. So someone said P1, right? So P1 has an arrow coming inwards that way. Can you see my mouse? You see my mouse?
Yes.
Grant?
Yeah.
Grant, cool. So P1 has an arrow going from R2 to P1, but P1 has an arrow going out to R1, right? So that one isn't a candidate because it has an outward arrow. P3 also has an outward arrow, so that's not a candidate. But P2 has an inward arrow and it has no outward arrow. So P2 has everything it needs, agreed? So what you can now do is say, okay, well, I can let P2 finish. I can let P2 finish. What that means is when P2 finishes, it'll give back the R1, right? So we move over to here. So P2 is now gone. And I'm looking at this diagram. What can I now do? How many instances of resource O1 have I got?
2.
Yeah.
2 of them.
And one of them is, you agree with P3, yeah?
Yeah.
Has the other one been allocated yet?
No.
Right. Is somebody looking for it?
Yes.
P1 is looking for it, isn't it?
P1.
So what I can do is I can reverse that arrow. So I get to this diagram, okay? So now I have these two and they've both been allocated. Now, what's the next stage? Now we go back to the start again. Find a process that has all its arrows inwards. And it is?
P1.
Exactly, right? You get the idea. So P1 has everything it needs. It has no outward arrows. So I go over here and I get rid of it. Yeah? And now I'm left with this. So I've got P3 is the only one left. It has an arrow coming in and it's looking for an R2, but R2 is now free, right? So I can give it that way and then P3 can finish. And I end up, they can all finish. That is not deadlocked, right? Because they were all able to finish. There will be other examples we will do in 2 weeks' time, and they won't be able to finish and they will be deadlocked, right? And you will get asked this in CA1. Okay? So, sorry, you will get asked, apologies, you will get asked this in CA2, not CA1. So don't panic. You are not doing these in CA1. CA1, as we'll discuss in a few minutes, is command line, scheduling, and some theory, all right? It's very like process of elimination, right? It's also very like avoidance, just in a different diagram. Because remember with avoidance, yeah, what we did was kept it in a safe state, which meant someone could finish, could give back what they had, and then we could give them what it gave back to other people. It's the exact same idea. It's just a different way of looking at it, right? Okay. So there's an example of deadlocked, and it's our classic nice circle. It's the one we've been looking at for the last hour, yeah, which is P2 wants R2, but R2 is with P1. P1 wants R1, but R1 is with P2. Classic 2 process, 2 resource deadlock, right? Last one. Sorry, not the last one. This one. This is not deadlocked, right? Why? Because P3 can finish. The minute P3 can finish, we can give the spare one to P1, then P1 can finish, then I give that one to P2, that'll finish, okay? Just another example. So, here we go. What do you reckon? What do we do first?
One finish and give it to another.
Do you know what? I'll leave you with that one, okay? And have a think about it, and then we'll have a chat about it in 2 weeks' time, okay? So I'll leave you with that one. Right. And I'll give you the answer to it in 2 weeks' time, because I don't think you gave it the answer to it tonight. So have a think about that one, because that's an interesting one. Okay, so let's go. The last thing to do tonight let's go and have a chat about your CA1. Okay, unless you have any other questions, which we can come to if you have them. So let's go and have a look at. So if you go over here, I've added this CA description, right? Section. So at the moment it just talks about CA1. So you should be able to see this. So your CA1 will run Tuesday in 2 weeks' time at 8 p.m., right? In a lab that I will advise in the next 2 weeks. We'll have a normal lecture session in that same lab from 6:30 to 7:40. I understand some people might be traveling from outside Dublin, so don't worry if you missed the lecture. Yeah, I won't be videoing the lecture, but the stuff I'll be covering, I released a video that basically goes through the same stuff. Okay, so don't worry about that. But obviously, you need to be there for the CA at 8. The CA is worth 20%, not 25, because we've only done 2 weeks' work, right? We'll have done 3 weeks' work then for CA2, so CA2 will be worth 30%. Okay? The exam then is the other 50. The CA1 will comprise of command line question based on the command line work we've completed in our online lab sessions, right? So those filters, head, tail, grep, cut, that stuff, right? Tar, yeah? Those ones. Okay, you'll get about whatever 8 questions or so, and you have to figure out. You know, I don't know. I can't, like, it could be like the ones we did earlier, right? So, I give you a different file and ask you, how many letters are in the first 10 lines, or how many instances of the word Hugo are in this file, whatever, right? So if you can do these and understand how they work, you'll get through it, yeah. And as I say, unless I say do it in one line, you don't need to do it in one line. I don't care if you take 4 lines or 5 lines to do it, as long as it works, right? If I do say do it in one line, you can either come up with a great way to do it using pipes or whatever in one line, or you can cheat and basically put in the semicolons in between each command as if they were on 4 lines, or you just put them on in one line, right? So it's up to you. I don't mind. Oh, here's a question. Will we be allowed to use a command line during the CA? Oh, Jesus, yeah. That's the whole plan, yeah. So you're allowed to use the command line to test all your answers, make sure that you're happy with them. And then the whole point is what you do is you then, I'd say, you give the answer on paper, so you just write in the answer onto the box and paper, okay? And sorry, the reason why I do it on paper, well, it's twofold reason. First one is it's much harder to cheat, right? And the second one is it's a lot easier and quicker to correct. So it means you get the answer, you get the corrections, you get your marks much quicker. All right. Because basically if I'm correcting on paper, it's really quick. Whereas if you have to do it on one of these Poxy Moodles or Brightspace things, it's a nightmare because you gotta go in electronically, you gotta look at it, it's terrible. Anyway, okay, so that's what we're gonna do. Scheduling questions, 5 marks for that. So 5 out of 20, 25% of the marks, right? I'll come to that lab computer question in 1 second, Gavin. 25% of the marks are for scheduling questions, right? So as I say, you don't need to be any command line expert. You don't need to have any previous experience in anything to be able to get those 25%, right? Those 5 marks. It's up to you. Some people, I don't know, have a mental block because there's numbers, but to me, they're pretty straightforward. So it's up to you. So I would make sure that you know how to do those if I were you, because that's 5 easy marks, I think. This is historically interesting, right? So what I do is I give you about 30 mixture of multiple choice questions or really short answer questions, right? And they're based on essentially anything we've done so far, right? Either in the lecture notes or the labs or whatever, anything I've done in the 5 hours, 6 hours, about 30, right? And the reason I do this is I don't like giving theory questions, right? Because as far as I'm concerned, the exam tests the theory, and so I'm sort of giving you marks twice for the same thing. So I don't really like it. However, I give a certain amount because it keeps you honest. It makes sure you keep up with the material, right? And that's why I do it. And it works out quite well that way. But it's interesting that if I were to do an analysis of how people do in these sections, historically, this section, I would say, is the one people do the worst in, which actually surprises me. I thought the command line would be the area that they do person, but a lot of times it's this. So you can read that whatever way you want. So 8, 5, 7, that's 20. All right. It's closed book. Whoops. Get back. It's closed book. Yeah. Now, when I say closed book, you're not allowed access to your notes. You are allowed to use the command line to test all your answers. Now, hopefully Google have got their act together before then, right? Because if they haven't, we're in trouble. So you are allowed to use, I think I showed you the last day, that for whatever reason, Google removed the man page, right? On their default offering, right? Did I show you how to fix that with the sudo unminimize thing?
Man.org, is it?
Now, did I show you? Unfortunately, it's not working. When you go into Google Cloud, right? You used to, up until this year, you used to be able to say man, whatever, unique, right?
Yeah.
And now that what they've done is to save space, they don't support the man pages anymore. But you can actually update it to download it, right? Did I show you the last day how to do that? Is it in the video? Sudo unminimize. Did I show you how to do that? Can't remember if I did.
I think so. I'm not sure.
Yeah, have a look back at the video. I'll have a look back at the video as well and see can I find it, or maybe someone could confirm to me at some stage whether I did it. Because all you have to do is literally when you it takes about 10 minutes, right? So all you would do is go in before during the lecture or whatever when we're doing it before 8 o'clock. Just go in and what I'll do is this is what I'll do. I'll show you how to do it in 2 weeks' time. So before 8 o'clock, you literally just go into one of these tabs and you type sudo unminimize and it downloads the man pages, right? So it means that you can use, because I don't allow you to go off here. Oh, stop, go away. Jesus. It's done now.
What about if, are we doing this on Google Cloud?
Yeah, well, you need Linux command line to do it. So you can either, I don't care, if you bring your laptop and there's a VM on it, you can do that, right? Or you can use Google Cloud. I don't mind. And sorry, we'll talk about that in 1 second. Let me finish first, right? Sorry, my apologies. It's closed book. You are not allowed to use Google Search Web. You are allowed to use console and the Linux man pages or command help for your command line work, right? Now, this is important, right? It's your responsibility to make sure your login works in the college. So make sure that it does work, right? Now, having said that, you don't actually, if you come along with your any machine that has a command line on it, you don't technically need Brightspace, right? So it's up to you whether you want to bother do that. If possible, I would make sure that everything's working before the date, right? As I say, you don't have to use Google Cloud Console. You can use a different Linux environment. So is anybody doing? Is anybody using a Linux VM with you, or have they used a Linux VM in the past with you? Or is it all Google Cloud?
I'm using.
Sorry?
I'm using a Linux VM.
Perfect, right. So if you use a Linux VM, right, that'll work perfectly as well, because all you're going to be doing is a few command line stuff, right? You just need to make sure you can copy a file to that Linux VM. That's your only issue, okay? So just make sure you can do that. Okay, so that'll work fine as well. And it might be a good idea to have that, even if you want to do it on Google Cloud, it might be a good idea to have that as a standby, okay? Because I don't know what's going on with this thing tonight, but it's really bonkers. It's very bad. So just watch out for that, right? And then the last bit is really important. So please don't come along and ask me for a supplemental for some stupid reason, right? Because if you do, I won't give it to you, right? I'll only give you a supplemental if you have a medical note if you're sick, or you have a work note saying that you cannot attend because you're away on business or you're whatever, you're in there till 12 o'clock. And I will insist that you give me the name of your manager, and I will check with them that you were actually required to work late if you say that, okay? So please don't mess with me on that, because I will check up on it, all right? So that's just me. I don't give supplementals unless those two reasons, okay? Now, have you any questions on that CA and don't worry if you haven't got them tonight and you think of them, you know, tomorrow or the next day. Just mail me, right? And again, if it's, I'll answer that in 1 second now, Tanvin. If it's something that I think everybody needs to hear the answer to, I'll send it out on an announcement, okay? If it's not something just one-on-one, that's fine. What time will the CA finish? I haven't written the CA yet, so I don't know exactly. Historically, maximum they go on for is about an hour and 20 minutes, okay? So about 9:15, 9:20, something like that.
Pierce, where do
Yeah.
we get the previous exams? Because I checked the library and they kind of coded differently.
They're all online as far as I know. Have you tried that? Have you gone to TUD past exam papers?
Yeah, it's in the library, isn't it?
Exam past papers.
Yeah.
You go in there.
Yeah.
And did it not work?
No, it worked, but the code of your of this class, I mean, it's coded differently than the code we have.
What do you mean?
Yeah, if you go to Tally, yeah. So let's say 2023, yeah. Semester 1. Yeah, you need to open each one, you know what I mean? Like
no, you don't. It's H3003.
that is the thing. Okay, so
Is there a search here somewhere? Yeah. So opsis H. Is that the code on it? We got that wrong. Opsis Y H303. Someone came up there maybe. Modified there. Oh, it's there. It's a space there. See it there?
yeah, okay, yeah, that's why. Okay.
Yeah, there we go. There it is there. Okay.
Okay,
So they should all be there. Okay. But again, if you have any issue, don't worry, just ask the question. Yeah. So I'm glad you asked it. No problem. Any other questions? Okay, so what I'll do is I'll process this video, I'll upload it, so it should be up there within the hour, okay? So all I can say to you is please practice the command line stuff, and I do realize some of you will find that harder than others because you've got more experience. And hopefully you've learned a little bit in the scripting class and you've done a bit of command line work with Art, and you will do more as you go along. And so between my videos and what Art gave you, I don't think I'm asking you anything too mad compared. I've already shown you, if you look at this video, on how to do all of those type questions. So yes, I understand that. I'm not going to be asking you to move around directories or do anything mad. So you need to know a lot more about Linux command line. It's literally, can you figure out how to use those commands to do certain things? All right. And that'll be it. Okay. So if there is no other questions, we will leave it. But as I say, feel free if you have any other questions to send them in over the next 2 weeks, right? I will do a video up with the process one, because as I say, I did the video and then there was no, I didn't share the screen, which was a bit stupid on my behalf. But anyway, believe me, that was an hour of my life that I lost, and I've done that before, and it's so annoying. But anyway, okay, listen, thanks very much for attending, much appreciated. Sorry if some of it was boring, but hopefully you got something out of it, all right? So I'll kill the video, stop recording, and I'll process it, okay?